Here's a question. Why does Instagram still work fine when servers go down across the world, but your bank sometimes just refuses to let you transfer money? Same planet, same internet, totally different behavior. These two systems made fundamentally different choices about what matters when things go wrong. And there's a theorem that describes exactly that trade-off. It's called the CAP theorem. First, some framing. The CAP theorem only applies to distributed systems, where data is spread across multiple servers, called nodes. On a single server, you have one database, one source of truth. Easy. But in the real world, you want to handle millions of users, survive failures, and serve every region with low latency. So you replicate your data across nodes: Singapore, London, New York. Now the question is, how do these nodes stay in sync, especially when something goes wrong? That's what CAP addresses. CAP stands for consistency, availability, and partition tolerance. Let's define each. Consistency means all nodes see the same data at the same time. The moment a write completes, every read on any node returns that latest value. Update a username to bobnew, and every server returns bobnew. Availability means every request gets a response. Always. It might not be the freshest data, but the system never errors out. Like a 24/7 store, maybe yesterday's bread, but always open. Partition tolerance means the system keeps working even when nodes can't talk to each other, a network split. And here's the thing, in any real system over a network, partitions will happen. So partition tolerance isn't optional, which means the real choice is this. When a partition hits, do you stay consistent or stay available? The classic way to picture CAP is this triangle: consistency, availability, partition tolerance. The theorem says you can only fully guarantee two of the three at once. CA, consistent and available but not partition tolerant. CP, consistent and partition tolerant but not always available. A P, available and partition tolerant but not always consistent. And since partitions are mandatory in distributed systems, real databases are really choosing between CP and a P. The C corner is mostly single-node setups. First, CA, consistency plus availability. Every node has the latest data, and every request gets a response. The write flow. The client writes to the primary, the replica confirms, and only then does the client get an OK, rock-solid consistency. The catch: it can't handle a partition. If the link between nodes breaks, a CA system goes offline rather than risk stale data. Examples: MySQL or PostgreSQL with synchronous replication in a single data center. One location, controlled network, where correctness is everything. Now CP, consistency plus partition tolerance. It stays consistent during a partition by refusing requests it can't guarantee. Three nodes, A the leader, B and C the rule. To accept a write, you need a majority, at least 2 of 3. A partition hits. Node C is cut off from A and B. A client hits node C. C asks, "Can I confirm this is still accurate?" It can't reach the others, so it does the responsible thing and returns an error, unavailable. Why? Because the alternative is two different truths in one system. CP blocks writes on any side without a majority. Think Spanner, HBase, Zookeeper, or anything using Raft or Paxos. The classic case: inventory, so you never sell 16 items from 10 in stock. And a P, availability plus partition tolerance. Every node keeps accepting reads and writes during a partition, even if they temporarily disagree. The bet is that the data will converge once the partition heals. Nodes sync up and resolve conflicts. This is eventual consistency. During the split, node A writes key equals 5, node B writes key equals 7. Both succeed. The conflict gets resolved later, often last write wins by timestamp. Examples: Cassandra DynamoDB Ryak. The canonical case, social likes. If the count is off by 2 for a few seconds, nobody cares. Great for a feed, terrible for a bank balance. So how do you choose? Ask one question: what's the cost of stale or conflicting data? If it's catastrophic, money vanishes, inventory oversells, records corrupt, you want CP accept the downtime. Reject the ambiguous request. If it's tolerable, a like count off by 2, a slightly stale recommendation, go a P stay responsive and converge later. Banking and inventory lean CP social feeds, sessions and caching lean a P, and modern systems mix both, choosing per data domain, not once globally. One important nuance: CAP only describes what happens during a partition, but partitions are rare. What about normal operation? That's where PACELC comes in, an extension of CAP. Even when everything is healthy, you still trade off between latency and consistency. Want every read to hit the most up-to-date node? That's more coordination, higher latency. Want faster reads? Serve from the nearest replica, but it might be slightly stale. It's why DynamoDB lets you pick eventually consistent reads or strongly consistent reads. Every distributed system is making trade-offs all the time, not just during failures. So to recap, when a partition occurs, you choose between consistency and availability. CA, consistent and available but no partition resilience. CP, consistent and partition tolerant but may reject requests. A P, available and partition tolerant but eventually consistent. Since partitions are inevitable, the real question is always CP or a P, and the answer depends entirely on what your data means. Next up, the PACELC model and tuning consistency at the query level. Drop a comment on which database topic you want next.